Welcome back, folks. Going a little further with nodal analysis. We're going to look at a problem with a dependent supply, just like we did with mesh. And it's going to follow kind of the similar pattern, okay? We're going to do nodal analysis the way we've been doing it. And we're just going to add that one little step where we need to write an expression for the control variable and do a little substitution. If we can do that, dependent supplies, not a problem, okay? So let's take a look at a problem with a dependent supply like that, and let's use nodal analysis. Okay, so we're trying to find I out. Okay, and it turns out that I out is also the control variable, so that's kind of a convenient thing for us. We're going to write the expression once. Not always the case. Sometimes it can have a different name, but here it is. Okay, so we label our non-reference nodes. I see one here, here, and here, right? Remember that A and C all connect up to all of these components. Passive components get a arbitrary current direction. Okay, so I'm going to pick those current directions, and that's what I'm going to use to get my signs correct. Okay, are there any voltage supplies? No, there aren't. Okay, so that's a question I usually ask you and make you struggle to respond. There are no voltage supplies. There are only current supplies. So we're going to write 3 KCLs in this case. Okay, so 3 KCLs, not red. Let's go with white. 3 KCLs is all it's going to take because that's what we have for unknowns. Okay, so I'm happy with that plan. So let's just go ahead and do it. Right, KCL for node A. There's 3 things connected to it. I'm going to start with this current here, and it is leaving A. Voltage at the tail is VA. Voltage at the tip is 0. I'm going to leave that off, and that's going to be over the 8 ohm resistance. All right, looking at this current, it's constant 4 amps. Sorry for the spacing of that. Someday I'll figure out how to fix that, but not today. Moving fast and trying to get these done. Okay, so we're leaving node A, and we have a magnitude of 4 for that constant current. Last one for this node, this one's leaving. VA is at the tail, VC is at the tip, and that's over 1 because of that 1 ohm. Okay, and that's equal to 0. Okay, a little bit of algebra. Let's see, we've got minus 9/8 VA minus plus VC. That negative distributes. And we pull the 4 over by adding it to both sides. Okay, I'm happy with that. We're ready to go. That was A. That one's like everything else we've done. Now we're going to have the dependent supply come into play for both B and C, because look over here, the dependent supply flows out of B and into C. So it's going to involve itself in both of those nodes. Because of that, I'm going to say, okay, well, it doesn't matter when you do this as long as you do it before you need to do the substitution, of course. Let's write an expression for the control variable. So our control variable, also our output, is going to be I out, okay, and it's labeled there, and the voltage at the tail is VA, and the voltage at the tip is 0, so we've already used this current, right? And we're going to divide by the resistance to make it a current. Okay, so if that's a current, I'm going to make sure I have a voltage over a resistance, and that's going to give me the correct unit. Volts over ohms is amps. Okay, so that's important because we're going to substitute that. And we're going to substitute that in when we write these 2 equations. So let's write the KCL for B. Let's see, we've got 4 amps flowing in, okay, because now it's going into B. We've got this current leaving, so it's minus VB is at the tail, 0 is at the tip, and that's over 2. Okay, and then this current's leaving, and it's 2IO, and that's everything going in or out of B, so that's equal to 0. Now we make our substitution. So we take this and we substitute it in for that. Okay, I'm going to bring the 4 over. Got to do it eventually, so might as well do it now. Negative 1/2 VB, and then we have negative 2, and I'm going to substitute in for VA over 8, and negative 4 on the right hand side as I move that over. Alright, that looks like 1/4. So if I was going to write this a little nicer, let's see if I can squeeze. Where do I want to squeeze it in? Up here? I'll do it down here. Okay, so it looks like negative 2/8, which is negative 1/4 VA. And I'm changing the order of the terms. And I'm changing the order of the terms because if I don't do it now, I'm going to screw it up when I put it in the matrix. And so that's another one of my habits, is when I'm working towards my final form, I like to put my terms in order that of the columns in the matrix form. That way, when I plug it in, I don't have to pay attention and potentially get something wrong. Okay, 1/4 VA and 1/2 VB equals negative 4. Okay, that one's in good shape. All right. Let's get the initial form here. I'm going to write it here, and then I'll cut and paste it and bring it down so that I can work the algebra with a little more room. But I've got 3 things connected to C. So let's see, we've got VA minus VC over 1. That's this current. It's positive because it's flowing in. Voltage at the tail minus voltage at the tip over the resistance. Plus 2IO, because that's now flowing in. And then this one's leaving, and we have VC minus 0 over 4. Okay, and that's everything to begin with. And then I'm going to steal this and bring it down. This is the KCL for C. Wow, that's white. Let's try that again. There we go. Look at that. Always set your background color, folks. Okay, so let's bring this down here and give it the proper label. It is the KCL for node C. Okay, so 2I out is still VA over 8, right? So I'm going to break these up. So this is going to be VA minus VC plus 2 times VA over 8. So that still looks like 1/4. And minus 1/4 VC, and that's equal to 0. So now we've just got a combined term. So this is 5 1/4, or 5 quarters, not 5 1/4, 5 quarters VA. And we have minus 5 quarters VC, and that's equal to 0. Okay. So, 3 equations, 3 unknowns. Let's go ahead and solve it. But each of the equations is a bunch of constants, and the unknown node voltages. I got rid of that control variable. Right, that was the whole point of doing that substitution, was to get rid of that control variable. Let's bring that one up there. Give myself a little more room here. Okay, 3 by 3. So we got 5 quarters, 0, right? There is no VB. You got to watch out for that one still. Negative 5 quarters. And the right-hand side is 0. Invert this matrix. Don't screw that up. I know some people who will take off points for that. There's 0, negative 1/4, negative 1/2, 0, and negative 4. That was from this equation. And then negative 9/8, 0, 1, and 4. All right. Dink, 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 dink. That's going to give us VA, VB, and VC. So the rest is calculator work. While I'm drawing this, I'm hoping you're fumbling with your calculators. I'm going to fumble with mine now. Your favorite part of the videos, right? Okay. 5 divided by 4, 0, negative 5 divided by 4, and 0, negative 1 divided by 4, negative 1 divided by 2, 0, negative 4, negative 9 divided by 8, 0, 1, 4. Alright, so that gives us negative 32 volts, 24 volts, and negative 32 volts. Okay, interesting. Those are the same. So that tells me that there's no current flowing through that 1 ohm resistor on the top because it has the same potential on both sides. Okay, but we're not done yet, right? We're not done yet because we got to find I out. And we already have an expression for it. So I'm really just going to steal that expression because it's the same. We already wrote it. Why not reuse it? Okay, the difference now is we know what VA is. Okay, so we plug in negative 32 from up here. Negative 32 divided by 8 is negative 4 amps. Okay, so first dependent supply problem. I'm hoping it wasn't too much of a departure from what we've been doing so that you feel comfortable that you can do that one extra step with a little bit of substitution and get to where you need to go. This dependent supply is a current supply and it's controlled by a current. So it's a current controlled current supply. Look for what type of supply it is by looking on the inside. Okay. We're going to do some more of these. They take a little practice, so we're going to get that practice. Stay tuned. Good luck.